Hi guys, welcome to Basic Bit. Today is December 3rd, 2020, and the problem we're going to be solving is increasing order search tree. So given the root of a binary search tree, rearrange the tree in order so that the leftmost node in the tree is now the root of the tree, and every node has no left child. A binary search tree, also known as a BST, is a more specific form of a binary tree. So this tree on the left here is a binary tree, but it's also a binary search tree because not only does each node have two children, but all of the nodes in its left subtree is less than 5, and all of the nodes in its right subtree are greater than 5. And this property holds true for every single node. So if we're looking at node 3, everything in its left subtree is less than 3, and everything in its right subtree is greater than 3. A neat property about binary search trees is that if you traverse the tree in order, then you're going to end up with this ordered tree on the right. So in order traversal means we're going left, root, and then right. Up our solution. So first, we're going to write a helper function that does the in-order traversal. If you need help writing this part, check out the video from December 1st, where I go into more detail about in-order traversals. But basically, here we're handling the base case. So if there's not a node there, we're going to return an empty list. Otherwise, we're going to return the in-order, we're going to call in-order traversal recursively on the left subtree. And we're also going to call in-order traversal on the right subtree. And in between, because we're doing in-order traversal, we're going to add a list with the value of the current node. So if we call this function in-order traversal on the root node, we should get a list. And this list will be in incrementing order. So essentially, we can iterate through this list to create the ordered search tree that we want to return. We do have to keep in mind that potentially the root that you're given is a null value. So then in that case, if there's no value in list, we're just going to return none. Otherwise, we're going to set a pointer to the first value, to the first node in the list. So, well, we're going to create a node out of the first value in the list. So tree node equals list indexed at 0. And we're going to keep a pointer pointed to this first node because ultimately we want to return the root of this new tree. Now we can iterate through the rest of the list. So we already put the value indexed at 0 into a tree node. So now we want to iterate through the remaining values in the list. So from range 1 to length of list, we're going to create a current node that contains the value indexed at I. The previous node, so this new node is going to be the right child of the previous node. So previous.right is equal to current. But we also have to, after we do that, we have to move the previous pointer to the right so that it now points at current to prepare for the next iteration of the loop. And finally, we can return answer. So our answer looks the same as the expected answer. Go ahead and submit. And it was accepted. So I feel like the problem today would also be considered an easy problem. Let's see what the rest of the week looks like.